each other. This is the Russians' Soyuz capsule. With the space shuttle retired, it is currently our primary mode of transportation for sending 3 astronauts to the ISS. Unlike our previous capsule systems, the Soyuz does not land in the water, but directly on land. The Soyuz lands with the help of parachutes and retro boosters. The main chute slows the Soyuz to a descent rate of about 16.5 miles per hour, which is still too fast for a comfortable landing. 1 second before touchdown, 2 sets of 3 small engines on the bottom of the vehicle fire, slowing the vehicle to soften the landing. Further cushioning the impact of landing are the crew seats with their custom-fitted liners. The liners are made pre-flight, individually molded to fit each person's body. This ensures a tight, comfortable fit whenever the module lands on the Earth. Now, with the Soyuz capsule, they can get to the International Space Station in as little as 6 hours, but they give them 2 days, so they have to sit knee to knee 2 days in that small little capsule. And the reason for that is your body's reaction to zero gravity is to vomit. So that wouldn't be too pleasant to show up at your neighbor's door and then vomit straight into their laps, so they give them that 2 days so their stomachs can calm down. Alright, ladies and gentlemen, you're going to follow me down to our second stop, which is our space vehicle training area. As you make your way down the hallway, you're going to notice you're passing up a large nose portion of the shuttle. This is going to be back towards the ISS. This is the Crew Compartment Trainer, or the CCT. The CCT was used to help our astronauts train for space shuttle missions. It can rotate both vertical and horizontal positions for launch and landing procedures. Since the shuttle program is retired now, this mock-up will eventually be moved to a museum. Now, towards the center of the facility, just to the left of the CCT, you will see a white mock-up of the Orion capsule. Previously called the Constellation Project, Orion will be the next exploration vehicle that will carry up to 4 astronauts into deep space. It will provide emergency abort capability during the climb to orbit, sustain the crew during space travels, and provide safe re-entry from deep space velocity. The European Space Agency, in partnership with NASA, is designing and developing the service module for the Orion spacecraft. Orion will serve as an exploration vehicle that will transport astronauts to celestial bodies in our solar system, such as asteroids, the moons of Mars, and one day, Mars itself. And just something to go over, something to point out here, Mars is actually the only planet, as far as we know, that's inhabited completely by robots. Just a little bit of food for thought. Now, just to the left of that, you'll see a large blue structure. Looks like it's in the shape of an H. This structure is the 6-degree freedom dynamic test system, otherwise known as the docking simulator. It is used to test and analyze new docking systems. Whenever you see a spacecraft on TV, it looks as if it's just floating. However, it is traveling at the incredible speed of 17,500 miles per hour, or 28,100 kilometers per hour, which is roughly 5 miles per second, or 8 kilometers per second. To put that speed into perspective, if you took a plane flight at that speed from Houston, Texas to Paris, France, the trip will only take you 17 minutes. When traveling at these immense speeds, exact precision at low speed is required to dock 2 vehicles together, so the docking hardware and sensors are developed and extensively tested here first before attempting any docking in space. Now, if you imagine, folks, the ISS has to go at that speed of 17,500 miles per hour. Any slower, it'll fall back down to Earth. Any quicker, it'll actually break orbit. At that speed, they get to go around the globe every 90 minutes. In just one 24-hour time period, they get to see 16 sunrises and 16 sunsets. That to me is a million times better than cable TV. Now, the large white pole to the left of us, is a functional model of the onboard ISS arm, also known as a robotic motion platform or the Canada arm. It is designed to work in Earth's gravity, unlike the ISS arm, to help train the astronaut crew for the construction of the ISS. Now, whenever they used to train the astronauts on this, they had a little screen set up down here, much like they would out in space. Well, down here, they can look over their shoulder and look directly at the arm. Out in space, there's no way you can look directly at the arm. So the engineers thought that that was kind of cheating. So they put up a black curtain behind the astronauts so they wouldn't peek over their shoulders. So just keep in mind that even astronauts cut corners at their own jobs. All right, ladies and gentlemen, you're going to follow me down to our third and final stop, which houses our robotics and multi-purpose vehicles. National Aeronautics Space Administration. Yeah, just NASA is just American, but they don't just work with themselves. They work with everybody. Yeah, like you said, that we send our astronauts to Russia, start seeing so they can learn Russian. And we launched with the Soyuz capsule that's back there. That's Russian. So since 2011, we've been using the Soyuz capsule to go to and from the International Space Station.
So people that
Japanese, Canada. Let's see. Yeah, Russia's Roscosmos. There it is. Just to make sure. Yeah, Roscosmos, the European Space Agency, Japan's JAXA, and Canada's CSA. Those are the nations that we mostly work with, but there's about 15 of them. But I don't know if all 15 of the nations, just those 5 that really work well together. I know China has their own, and I think they got invited to help out with all this, but I think they just kind of refuse to want to do their own thing right now, which is probably the same for a lot of other countries, like those other 10 countries that we don't really associate with. Not that we don't associate with them, it's just they're not as part of the program as much as all the other ones are, like the 5 powerhouses.
Cool.
All right, ladies and gentlemen. In this area, for those of y'all closest to the end of the hallway, this is going to be our vehicle to the left with the American flag on it. For those of y'all towards the back of the line, this is going to be the vehicles right next to the ISS arm. But what you're seeing is our Space Exploration Vehicles, or SEV. The surface exploration version of the SEV has the cabin mounted on a chassis with wheels that can pivot 360 degrees and drive about 6 miles per hour in any direction. It's about the size of a pickup truck with 12 wheels. It can house 2 astronauts for up to 14 days with sleeping and sanitary facilities. The way they found this out is they told 2 astronauts stay in there for as long as possible. About 14 days is all they could stand. Likewise, the in-space version of the SEV would have the same pressurized cabin on a flying platform and also includes manipulator arms and an airlock for handling satellites and other objects of interest. The rover has 6 pairs of wheels, which can move independently from one another. This style steering allows the vehicle to turn on a dime with a 0 turning radius and drive in any combination of forward and sideways. NASA has developed a new spacesuit for both the surface and in-space versions of the SEV. Astronauts can work in shirt sleeves in the safety of the vehicle's cabin, and when they need to, or want to for exploration missions, they can quickly enter and exit their spacesuits through the suit ports. These protective suit ports keep the astronaut suits outside, allowing the spacewalk to start in just 10 minutes, compared to the current spacesuit on the ISS, which can take approximately 2 hours to put on. With the newly designed spacesuit system and the ability to live on the surfaces of celestial bodies, astronauts will be able to stay for longer duration missions to further the exploration of whatever celestial body they may be on. Now last and certainly not least, and one of my favorite subjects here, down here at the end, right in front of us, you'll find a version of the Robonaut. Robonauts were created to help our astronauts maintain and repair parts of the ISS. Robonaut has 2 hands, each with 5 fingers. His fingers are so accurate that he can turn a single page of a book without ripping it, and can utilize standard tools designed for humans, such as a powered screwdriver. Now, without the operation of a human, the Robonaut is essentially useless. He had to put on a helmet to become his eyes and see through the 2 mounted cameras he has within inside, and 2 gloves to become his hands, so he can work with them from the safety of the ISS or even down here on Earth. And yes, he has legs, but those legs don't carry him. They're not strong enough. All they could do right now is to anchor himself to some place on the ISS or even push himself off of the walls to maneuver around. And something that I most recently found out about the Robonaut that I find extremely interesting is that those gloves that the astronauts wear actually simulate touch. So anything that you touch with the Robonaut, you could feel through the gloves. A good example would be giving somebody a handshake through the Robonaut. You'll swear that you could feel somebody's hand in your own through the glove. That's cool. I really wish that I was qualified to try these gloves, but unfortunately I'm not. But that's all the time that we have for it, unfortunately. So we're going to be exiting through the double doors down here at the end of the hallway. I'll be at the bottom of the staircase to answer any questions you may have to the best of my abilities. And folks, return to the same seat on the tram just so we can load up quicker and get to our next stop a lot faster. Thank you very much, ladies and gentlemen.